Cosine law applications. Communication question 1. A quick note on cosine law. Well, there are two special cases where sine law cannot be used and cosine law comes to our rescue. The two cases are when we are given side, 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 all three sides as shown here, or we are given side, angle, side. What we're trying to say is side and angle is included angle, right? Or the angle contained between the two sides. If that is given, then we cannot use sine law, but we can use cosine law. So in a way, if you have a triangle kind of like this, where what is given to us is the two sides and the angle contained, right? In that case, we cannot use sine law, because for sine law you need at least one pair of opposite side and the angle, which we don't have in this case, so we cannot use, right? And here also, if we have three sides, that means we know this side, and this side, then also, we don't have a set with angle and a side, so we cannot use sine law. So in those places, when three sides are given, or two sides with an angle contained or included angle, we use cosine law. So let us say we have this kind of a situation where we have two sides and an angle. Then we can find the third side. Once we get the third side, then we can use the sine law. Do you see that? So once we get the third side, then we have this pair of angle with the opposite side. And then we can use sine law to find the other angle. So that is how the triangles are solved. So the first step in these cases is to use cosine law to find one of the sides, right? When I say yes. To find the side, we can use this formula. A square equals to b square plus c square minus 2bc cos A. This formula is very straightforward. It's kind of like this. If you're here on the vertex A, and now let's say you want to find this side, the side opposite to the vertex A, then the formula says square these two sides, add them up, and take away 2 times product cos of this, correct? Because that is the situation, and in this situation, the angles could be anything. Let's say PQR is a triangle. Let me write a new formula. PQR is our triangle, right? So we want to find the side, this, which is small p. So small p square will be equals to, this is side Q, right? Q square plus side opposite to R is R square minus 2 times QR and cos of P. Cos of P. I should write capital P. Now you see, you are given the sides Q, sides R, and the angle P, right? So all these things are known, and from those known things, we find opposite side P, right? Now once you find side P, then you can use sine law to find the angle, correct? So that is how this situation is solved, where two sides and included angle or contained angle is given to you. Now let's look into a situation where three sides are given to us and we need to find the angle. Well, in that case, we rearrange this formula, right? We rearrange this formula and try to figure out what A is. So if you rearrange it, we can bring it to one side, so you get b square plus c square minus a square, and then you divide by 2bc and then take cos inverse. So angle A is cos inverse of b square plus c square minus a square divided by 2bc. Likewise, you can get other angles. So let me show you here. So what we do here is, let's say that is the general formula, then we can bring 2qr cos p to this side. So we'll write this as 2qr cos of p is equal to, so when we bring out this side, we get q square plus r square minus p square. So q square plus r square minus p square, correct? Let me write this. And then we can divide by 2qr. So we get cos p equals to q square plus r square minus p square divided by 2qr. And angle P is equal to cos inverse of all this, that is q square plus r square minus p square over 2qr. So that becomes the formula in general for finding the angle. So cosine law can be used in these two situations, and these are the formulas. Now we will do a couple of questions to practice, okay? I hope you understand and appreciate the method, and let's see how it goes. Thank you and all the best.